So related rates is pretty much you want a rate, so you want one that's y in terms of x, and you're given a rate that's y in terms of u, and a rate that's u in terms of x. Does that make sense? So you're given two other rates, and you use those two rates to create a new rate. That's pretty much what it's about. So let's have a look. It's not too tricky, I don't think. You're just trying to get one rate. So looking at the other rates to try and get that rate. So it gives us the first one, and it gives us the second one. So volume in terms of time, rate becomes 40 R. That's about it. And then we can have similar situation. So now it wants, I don't know, it could be maybe work in terms of maths or something. So we want W up the top, so let's keep this. And we're going to have to flip this guy. So that one is 2t, and that one is, because we flipped it, it becomes 1 over 12. So when you equate those, t over 6. So another big part, first establishing the variables and the rates. The other part you need to be aware of is the units at the end. So right now we don't really know what WMT are, hasn't really established that. But if it tells you, you know, for example, T is time, in terms of time, there's going to be some on here. It's going to be something in terms of seconds. So if that's volume, it could be like meters cubed per second or something like that. And this is called unit analysis. All right, so you got a balloon. It's increasing. No, it's losing air, sorry. So that's key. Losing air at a rate of 120 centimeters cubed per second. So like I said, unit analysis. Any thoughts? Centimeters cubed per second. Perfect. So we got a volume change over a time. Yep. Determine the rate the radius is changing. Any thoughts what that could be? Yep, dr dt. So it gives us that one. It wants us to find dr dt, the radius is changing, which is the radius over time, when the radius is 4 centimeters. Yeah, so if it doesn't specify, determine the rate the radius is changing, it means time. Radius is changing as time. So dr dt is what it wants. Is there anything else we know? It says state any assumptions. Perfect. So we assume it's a sphere. The volume of a sphere is 4 over 3 pi r cubed. So we have dv dt, we have dr dt, we have a volume in terms of r. Considering what I talked about before, what do you think is the next step? We want dr dt. If we find dv dr. Perfect. You figured it out. So we find the derivative of this. And now we have enough information, hopefully. If we have this one. So dt is on the bottom. We want to get rid of the dv, so we're going to have to flip this one. And then those two cancel out and you're left with just dr dt. So substitute this in. Substitute this in. Oh, it has to be the inverse. Thank you for that pickup. 120 divided by 4. 30 over pi r squared is our dr dt rate of change. So we used the information it gave and we used a strange form of the chain rule to figure out dr dt. Now remember my unit analysis. What's r, do you think? Centimeters, yep. And what's t? Okay, and it's saying determine the rate. The radius is changing when the radius is 4 centimeters. So one last step. Sub in r equals 4. It's losing that much radius per second.